Kia ora, Year 12 and 13. I'm going to start trying to catch up on some scholarship calculus videos, and I thought I'd start with this question from 2019, which is about twin lambs. So before I start, I just wanted to say thank you to Pam, whose Flickr photo I've used here. And this photo is not what this question's about, because this photo is showing us this beautiful big Romney sheep that's had triplets. And you can see that one of those triplet lambs is quite little. So the question we've got in the scholarship calculus paper, very good New Zealand context, is about twin lambs. Okay, so if you want to go and see all of Pam's photos of her farm and her sheep, they are really cool, and there's the photo credit link there. So I know you didn't come to talk about sheep, you came to look at some equations. So we're told that ewes have got often have twin lambs during lambing season, and on a New Zealand sheep farm, it's been observed that over some time interval, so the time interval is sometime between 0 and TP, the mean probability that both twins have the same sex is given by this thing here. So this is another example of a question where you're given a formula that you haven't seen before. It looks really awful, but once you break it down, all you have to do is some level 2 integration. But we take quite a long time in this question to get to the point where we're actually integrating anything. So we've got some different things in here. We need to understand what the variable is. So the variable here is t, time, and we've got some constants, right? So this one here, TP, is the end of our time interval, and that's a constant. And we're going to be integrating with respect, not to that, but with respect to just t. And then we've got two probabilities sitting in here, PM and PF. So PM is the probability that one of the twins will be male, and that probability is given by this. And then PF is the probability that one of the twins is going to be a female, and A and B are both constants. And where we have to get to is that that integral is equal to this. So obviously you'll see in there that there's no PMs and PFs. It's pretty clear what we have to do here with the PM. We have to substitute that into there. But obviously we've got to do something with this PF. So you have to think for a minute, well, there's no expression given for PF, so what must it be? Well, sheep can be born with one of two sexes. They can either be born male or they can be born female. So if we're given PM, the only real insight in this question is to realise that PF must be 1 minus PM. And so we start working that through, and then we're going to square the expression for this, and we're going to square the expression we get for PF. We're going to clean up a whole lot of stuff, and then we're going to integrate with respect to t and substitute in. So this is a question that's very, very doable. I'd like you to pause the video now and try and get as far through it as you can before I do all of that. Okay. Okay, so here's PF. So PF is equal to 1 minus PM, which is 1 minus A plus A minus B over TP times T. Next, we need to square each of those expressions. So P of M squared will equal A squared plus A minus B squared over TP squared times T squared minus 2A times A minus B over TP times T. I'm going to do the same thing now for PF, and I'm going to group this term together until near the end. So this will give me 1 minus A squared plus A minus B squared over TP squared times T squared. Notice I'm roughly lining my working up with the line above as much as I can. And now I'm going to have plus 2 times 1 minus A times A minus B over TP times T. So let's add those two lines together. And we'll have A squared plus 1 minus A squared. So I'm going term by term here. So that's that done. And now I'm going to add these two plus 2 A minus B squared over TP squared times T squared. And this last one I'm going to go very slowly with. Let's just do it here first. So minus I'll do this one first. This is the plus one. So plus 2 times a minus b over TP times 1 minus AT. Now I'm looking, the reason I'm saying it slowly like that is because I've already had a look and I can see I'm going to be doing some cleaning up the common factors. And here I've got minus 2a times a minus b over TP times T. So we'll just fix some of this up before we go any further. And here, I'm going to write this now as a squared plus 1 minus 2a plus a squared. So we're going to have 2a squared minus 2a plus 1 plus 2 times a minus b squared. I think this is the most boring video I've made in a while. Now, what about the cleanup here? Well, the more we can clean this up before we start integrating, the better for us, I think. So we're going to have plus 2 times a minus b over TP into 1 minus a minus a times t. Right now, we're going to check that we haven't mucked that up. We've got 2 times a minus b over TP times 1 minus AT. And here we've got 2 times a minus b over TP minus the a. So that looks good. Okay, so that gives me 2a squared minus 2a plus 1 plus 2 times all of this plus 2 times a minus b over TP times 1 minus 2a times t. So that's what we've got there. So that gives me that t. So t is going to equal the integral of 1 over TP times all of that. Oh, where's my cursor gone? Hang on. Oops, wrong one. Okay, so t is going to give me this. 1 over TP times the integral evaluated at TP and 0 of all of that with respect to t. So here we'll have the constant multiplied by t plus 2 times a minus b squared over 3 t squared times t cubed, right? So this is a straightforward level 2 integral. Just a polynomial thing. Same thing here. We're going to have plus 2a minus b, 1 minus 2a over TP, and now that's going to be times 2 t squared. And you should see we're nearly there, right? Because a whole lot of those TPs are going to cancel out. Remember, this is the end of my time interval for the farmer. So what have we got? Well, we've got 2a squared minus 2a plus 1 TP plus 2/3 a minus b squared, and we've got TP cubed over TP squared plus a minus b, 1 minus 2a, TP times TP squared. So it's all of that minus, and then we're doing a show that question, so we need to show our bottom limit. So it's minus 0 for all of those. Now, cleaning a whole lot of stuff up, this gives me 2a squared minus 2a plus 1 plus 2/3 of a minus b squared. So this simplifies to TP, so times TP over TP. So that's gone. Plus a minus b times 1 minus 2a. This is simplified here, so we've got TP over TP. So that simplifies. Now we just have to get it now manipulated into the right thing. What did we want? Where's my question? Right, we need to get to 1 minus a plus b times 2a minus 1, plus that bit on the end. So we've got 1 minus 2a plus 2a squared, doing this bit, plus A, I'm doing this very stupidly now, right? A minus B, haven't had enough coffee, A minus B here, minus 2A squared plus 2BA plus that nice expression that is exactly how we wanted it, this bit here. Okay, so cleaning up this, what do we get? Well, we get 1 minus 2A plus A, so that gives me 1 minus A, and then I've got plus B into 2A minus 1 here and here, plus 2/3 of A minus B squared as required. So there you go. Thanks for watching. I will try and do some more of the 2019 paper over the next few days.